You think conservation in physics is simple. Energy stays the same. Momentum stays the same. Charge stays the same. You imagine neat quantities locked in a cosmic vault. Nothing lost, nothing gained, just careful bookkeeping. That picture feels solid. It feels responsible. It feels like physics doing accounting, but that picture is wrong. You think something is being preserved because it exists, as if the universe is trying to protect its valuables. As if energy is a thing that must survive. It isn't. You're used to asking what is conserved. You're rarely forced to ask why anything is conserved at all. And that omission matters, because once you look closely, the thing you think is being saved is not the thing doing the work. What's conserved isn't obvious, it isn't tangible, and it isn't what you were taught to picture. You were taught conservation as a kind of moral rule. Nothing disappears. Nothing comes from nothing. The universe keeps its promises. Energy, especially, is presented like a substance. It flows. It gets stored. It changes form but never vanishes. This feels intuitive because you already believe in things. You believe in objects that persist. You believe in quantities you can count. You believe that if something survives every transformation, it must be real in the same way a rock is real. So energy becomes a mental object, a fluid, a fuel, a cosmic currency. But this is where the intuition quietly collapses. Ask yourself a simple question. Where is energy? Not what form it takes, not how much there is, where it actually is. You can point to a chair, you can point to a charge, you can even point to a field, at least mathematically. But energy doesn't sit anywhere. It doesn't occupy space. It doesn't have edges. You cannot isolate it. You only ever calculate it after you describe something else. A moving object has kinetic energy. A stretched spring has potential energy. A hot object has thermal energy. Notice the pattern. Energy never appears alone. It is always an attribute, never a thing. And yet we talk about it as if it migrates, hides, waits. As if it survives explosions and collisions the way matter survives a reshuffling. This is wrong. Consider a simple collision. A ball hits the ground and stops. Its kinetic energy becomes heat, sound, deformation. But nothing actually moves from one place to another called energy. What changes our relationships, speeds, vibrations, arrangements of atoms? Energy is the number you compute to describe those changes. It is not what changes. That should bother you. Because if conservation were about saving a thing, you would expect that thing to be clearly identifiable. Instead, energy behaves like a shadow cast by your description. Change how you describe the system, and the energy changes too. In one reference frame, an object has kinetic energy. In another, it doesn't. Did energy vanish, or did your description shift? If energy were a physical substance, this would be impossible. Substances don't depend on who's looking. But energy does. Even worse, there is no single, universal definition of energy that works everywhere. In simple systems, it behaves nicely. In complex ones, it fragments. In curved spacetime, it can stop making sense entirely. A conserved quantity that sometimes cannot even be defined should make you suspicious, yet the myth persists because it's comforting. It replaces uncertainty with bookkeeping. It turns physics into accounting. You imagine the universe with a ledger. Debits, credits, totals that must match, but no such ledger exists. There is no place where energy is stored. No container holding the total amount. No mechanism checking the balance. The conservation law works without any of that. which means conservation is not protecting a thing. It is constraining something deeper, and until you let go of the idea that the universe is saving stuff, you cannot see what that deeper thing is. If conservation were a rule about protecting quantities, you would expect it to be loud when it breaks. Alarms, contradictions, impossible results that never happens. Instead, conservation fails quietly, so quietly that most people never notice. Take the expanding universe. Galaxies drift apart. Light travels for billions of years. And as it travels, it loses energy, not by scattering, not by absorption, simply by existing in expanding space. The light stretches, its wavelength grows, its energy decreases. You might instinctively ask, where did the energy go? That question assumes something must receive it. Nothing does. There is no hidden reservoir, no background field quietly absorbing the loss, no compensating gain somewhere else. The energy is just not there anymore, and physics does not panic. No law is violated, no theory collapses, nothing needs fixing, because in this situation, energy conservation is not broken. It is undefined. That should feel unsettling. In ordinary situations, you can define a total energy. Add this, subtract that, everything balances, but that only works when time behaves nicely, when before and after are clearly related. When the rules of physics don't change as the universe evolves. In an expanding universe, they do. There is no single, global clock ticking for everything. No universal now. You can anchor energy to. Without that, the concept of total energy stops making sense. And conservation doesn't protest. It simply steps aside. The same thing happens near black holes, or in strongly curved spacetime, or in accelerating reference frames. Energy becomes slippery, frame, dependent, sometimes local, sometimes not definable at all. If conservation were about preserving a physical substance, this would be catastrophic. Imagine saying, water is conserved, except when it isn't definable. Mass is conserved, but only sometimes. That would sound absurd, but with energy we accept it, because deep down, physics already knows something you were never told. Conservation laws are not universal commandments. They are conditional statements. They only apply when certain symmetries exist. Remove those symmetries, and conservation doesn't break, it dissolves. No explosions, no contradictions, just silence. This is the quiet failure most people miss. The universe is not struggling to preserve quantities. It is refusing to privilege certain descriptions. When time itself loses its uniformity, energy has nothing to anchor to, and so it fades not physically but conceptually, which leaves you with a disturbing realization. If conservation can vanish without drama, then it was never guarding a thing in the first place. It was enforcing a relationship, and that relationship has nothing to do with saving energy. At this point, you might still be holding onto a quieter version of the myth. Maybe conservation doesn't protect a substance, but surely it requires a process, a mechanism, some hidden bookkeeping that keeps the numbers consistent. A cosmic spreadsheet you never see. This is where Feynman's insight matters, because Feynman was unusually good at noticing when a story was doing unnecessary work. He didn't like explanations that smuggled in invisible machinery, especially when the equations worked perfectly without it. And conservation laws work perfectly without tracking anything at all. Imagine trying to enforce energy conservation manually. You would need to monitor every interaction, every collision, every field across the entire universe. You would need a reference frame, a clock, a definition of total energy that never wavers. None of that exists. Yet conservation appears anyway. This bothered Feynman, because if something always holds even when nothing enforces it, then enforcement is not the reason. So he stopped asking how conservation is maintained and asked a more dangerous question: what makes conservation unavoidable? The answer was not a thing, not a force, not a rule, it was a restriction. Conservation laws are not added to physics. They fall out of it. You don't impose energy conservation on a system. You discover it after you've written down laws that don't care about time. This is subtle. It means nothing is checking the energy balance. Nothing is making sure the book's close. The book's close automatically because there was never a book to begin with. Think of it this way. If the laws of physics behave the same today as they did yesterday, then certain quantities cannot change, not because they are protected, but because there is nowhere in the description for that change to appear. Energy conservation is not an active process. It is the absence of permission. Feynman emphasized this repeatedly. You don't need to know what energy is to know it's conserved. That alone should worry you. How can something be conserved without being clearly defined as a physical entity? Because conservation is not about entities. It is about invariance, about what stays the same when you shift your perspective. Once you see this, the ledger metaphor collapses. There is no cosmic accountant, no storage vault, no emergency system preventing loss. There is only a description that refuses to change when you slide time forward. And from that refusal, conservation emerges. Effortlessly, silently, inevitably, this is not how rules behave. This is how constraints behave. And once you accept that, you're ready to see what energy conservation is really tied to. You probably think time is the backdrop, a stage where physics happens. Tick, tick, tick. Events occur in time, and energy moves through time. That picture is comfortable. It is also wrong. Energy conservation does not come from energy. It comes from time. More precisely, it comes from time not caring when something happens. Imagine repeating an experiment today, then tomorrow, then a billion years from now. You expect the same outcome, not because the universe owes you consistency, but because physics has taught you to assume it. This assumption is so deep you rarely notice it. The laws of physics do not change with the date. They do not weaken on Tuesdays. They do not behave differently in ancient Rome. This uniformity feels obvious. It feels natural, but it is an assumption about reality, not a necessity. Now here is the uncomfortable step. If the laws of physics did change with time, energy conservation would disappear. Not gradually, not partially, immediately. You wouldn't be able to define a conserved energy at all. Why? Because energy is the number that measures how a system responds to time shifts. Slide the entire experiment forward in time. If nothing changes, energy exists. If something changes, energy has no stable meaning. This is not philosophy. It is a structural fact about how physics works. Energy is born from time, translation symmetry, from the fact that now is not special. No symmetry, no conservation. This means energy is not fundamental. Time symmetry is. Energy is a shadow cast by that symmetry. Once you see this, several strange facts suddenly make sense. Energy depends on your reference frame. It depends on how you slice time. It depends on what you call before and after. That's not a flaw. That's a clue. You were never meant to treat energy as a thing. You were meant to treat it as a bookkeeping consequence of time's indifference. And when time loses that indifference in curved space-time, in expanding universes, near horizons, energy conservation does not fail. It evaporates because it was never a rule to begin with. The universe is not preserving energy. It is refusing to notice when an experiment happens. And that refusal is stronger than any law you memorized. Once you've accepted that energy comes from time not caring, another belief quietly destabilizes. Momentum. You were told momentum is conserved because motion matters, because objects in motion want to stay in motion, because the universe respects trajectories. None of that is true. Momentum exists for the same reason energy does, not because something moves, but because space doesn't notice where you are. Imagine performing an experiment here, then moving the entire setup 10 meters to the left. Nothing changes. Not the outcome, not the equations, not the physics. You don't even think to ask whether the location matters. That question feels meaningless, and that meaninglessness is exactly the point. Space has no preferred position, no origin, no center, no marked spot where physics behaves differently. Because of that indifference, momentum exists. Momentum is the number that stays fixed when you slide a system through space and nothing changes. That's it. If space cared where things happened, momentum would not survive. Imagine a universe where physics behaves slightly differently near one special location. Move an experiment closer. Its behavior shifts. In that universe, you could not define a conserved momentum. Not because objects behave badly, but because space stopped being symmetric. Once again, conservation vanishes without drama. This also explains something that should have bothered you long ago. Momentum is directional. It has components. It depends on orientation. Why? Because space doesn't just ignore position. It ignores direction too. Rotate an experiment, nothing changes, no preferred direction, no cosmic compass. From that rotational indifference, angular momentum appears, not as a stored spin, not as a substance, as a constraint on how descriptions may change. You are not observing conserved quantities. You are observing the universe's refusal to acknowledge your coordinate choices. Momentum is not protected. It is unavoidable. Remove spatial symmetry, and motion loses its accounting, just like with energy. At this point, a pattern should be uncomfortable. Every conservation law you trust is quietly pointing away from objects and toward indifference, toward what reality refuses to privilege, and that leaves only one possibility. Nothing you've been calling conserved was ever the main character. By now, the pattern is no longer subtle. Energy comes from time not caring. Momentum comes from space not caring. Angular momentum comes from direction not caring. Every conservation law you rely on emerges from indifference, not from protection, not from storage, not from survival. This is where a deeper mistake finally collapses. You think conservation laws describe things, quantities that exist independently of you. They don't. They describe relationships between descriptions. Change how you label time and energy changes with it. Change how you label space and momentum reshapes itself. Nothing physical needs to move or transfer. Only your coordinates shift. This is why conservation laws feel abstract. Because they are. They are not statements about matter or fields. They are statements about what cannot depend on arbitrary choices. This is stronger than any object-based law. Objects can decay, fields can fluctuate, particles can vanish. Symmetry does not decay. It either exists or it doesn't. When it exists, conservation is forced. When it doesn't, conservation is meaningless. This reframes something subtle but important. Physics is not telling you what the universe contains. It is telling you what the universe ignores, and what it ignores shapes everything. The conserved quantities are not the foundation. They are the footprint. They are what remains invariant when you slide, rotate, or delay your description, and reality refuses to react. Once you see this, asking what is conserved becomes the wrong question. The real question is, what transformations leave the universe unchanged? Answer that and conservation laws fall out automatically. No enforcement, no mechanism, no explanation required. Just structure, and structure does not care whether you find it intuitive. One chapter remains. And it removes the last comfort. Most people keep the idea that the universe preserves anything at all. At the end of all this, there is a quiet but unsettling realization. The universe is not conserving anything because it values it. It is not preserving energy or momentum or charge out of some cosmic sense of order. It is doing something colder. It is refusing to acknowledge your perspective. When you shift time, nothing fundamental reacts. When you shift space, nothing notices. When you rotate your coordinates, reality does not flinch. From that indifference, everything you call conserved emerges, not as protected quantities, but as invariants of description. The universe does not safeguard numbers. It does not care if totals match. It does not balance books. It simply does not change when you describe it differently. This means conservation laws are not promises. They are consequences, and consequences are fragile. Change the symmetry, and the conservation law evaporates without protest. There is no failure, no violation. No repair needed, only a reminder that these laws were never about survival, they were about sameness. This reframes your relationship with physics. You are not discovering what reality keeps. You are discovering what reality ignores. And that is a far more unsettling kind of order, because it means nothing is guaranteed to persist except indifference itself. No object, no quantity, no value, only the quiet fact that the universe does not care where you stand, when you look, or how you label what you see. From that refusal, all structure flows. Not because reality protects meaning, but because it never had any to lose.